My name is Paige Pennington, and I'm doing problem number 6. For part A, partial derivative of x, we're only looking at the first two terms. We use the power rule here, 3 over 6 times x squared, and then here we leave the y alone because we're only looking for x's, and the derivative of x is 1. So this simplifies to be x squared over 2 plus y. Next, for the partial derivative in terms of y, we're only looking at the last two parts. We leave the x alone, and the derivative of y is 1, and then again the power rule, 2 fourths y, which simplifies to be x minus y over 2. Next, it was easiest to isolate a variable in the second equation, so I did 2x equals y, just manipulating the variables up here, moving y to the other side, and multiplying by 2. In the original equation, there is a y, but I have substituted it for the 2x. So when I set this equal to 0 in solver, I produced x equals 0 and negative 4. Now substituting this back into the equation that I made, 2 times 0 is 0, so that's the y value, and 2 times negative 4 is negative 8, so that's the other y value. So the four coordinates I have are 0, 0, 0, negative 8, negative 4, 0, and negative 4, negative 8. Now for the second partial derivative, I look at f of x to get f of xx, only looking at the parts with an x. So only this one. Using the power rule, this becomes 2 over 2x, which simplifies to x. Next, f of xy, we're looking at the partial derivative of f of x, only at the values with a y, which would be this. The derivative of y is 1. Next, for the fyx and fyy, we're going to be looking at the partial derivative of y. So we're only looking at the terms with an x. For this, the derivative of x is just 1, and we know that this is correct because the other value, fxy, is also 1. Lastly, fyy, we're only looking at the values that have a y, which would be here, and the coefficient of y is negative 1/2, so the answer for that is negative 1/2. Lastly, for the determinant test, I set up my matrix and cross-multiplied to get negative 1/2 x minus 1. For 0, 0, I substituted this in for the determinant test and got a negative value of negative 1. Knowing that, that means it's a saddle point. For 0, negative 8, it was the same result because we're only plugging in the x and they have the same x value, so this is also a saddle point. When I substitute negative 4, 0 into the determinant test, I get a positive value because this turns into 2 minus 1, and the same result is true for negative 4, 8, it's also 2 minus 1. Since these are both positive, you have to go to the next step, which is fxx. When I substitute fxx, which is x, negative 4 equals x, so f of xx is negative, meaning that these are maximums. So there's a relative maximum at negative 4, 0, negative 4, negative 8, and there's a saddle point at 0, 0, and 0, negative 8. Thank you.